Hey class, in today's lesson we're going to talk about exponential functions and their graphs. The objectives are to recognize and evaluate exponential functions with base A and to graph exponential functions. So the definition of exponential function is the exponential function f with base A is denoted by the function f of x equals a to the x power, where a is greater than 0, a does not equal 1, and x is any real number. A has to be greater than 0 for this to really work, and specifically it can't be 1 because 1 to any power is itself, thus it wouldn't be exponential. So in example 1, all we're going to do is practice evaluating. So this is nothing but calculator work. So if you evaluated each of these functions, you would get 2 to the negative 3.1 power is about 0.117. 2 to the negative pi is about 0.113. 12 to the 5/7 power is about 5.9. 0.6 to the 3/2 power is about 0.465. In this example, we are asked to graph this function, so we're going to use some basic numbers. To graph, we will use the values -2, -1, 0, 1, and 2 for our table. So if I substituted in 2 to the negative 2nd power, remember negative powers are actually put under the denominator or into the denominator, so this really becomes 1/4. The next one, if I followed suit, would be 1/2, then 1, 2, and 4. So if I graph this as an ordered pair, we would have, go ahead and put some markings on here. All right, -2 and 1/4 is just a little below. -1 and 1/2 is halfway. 0 and 1 is halfway. 1 and 2, and then 2 and 4. And so this graph would essentially take on this shape here. Okay, without going to the next screen, because it wants you to put it all in the same graph, we're now asked to graph the function y equals, or specifically g of x equals 4 to the x. I'm saying y, but remember the connotation, g of x is just letting us know that it's a function and that it's a function of a different name. So if I substituted -2 in here, I would have 4 to the negative 2nd power, which by the way is 1 over 4 squared, which is really 1/16. If I keep with that same pattern, I would have 1/4, 1, 4, and 16. Now obviously I don't have enough space for all of that, but I can attempt. So -2 and 1/16 is way lower than original. -1 and 1/4 is still lower. I have 0 and 1, so the same first point, or same y-intercept. I have 1 and 4, and then 2 and 16 would be somewhere way up here. So this graph is just going to take on a slightly more shape like that. All right. Let's move on to example 3. By the way, the red portion is our try 2. And again, this is the try 2 that was graphed on the last one in red. Okay, example 3, it says on the same coordinate plane, we want to graph the functions f of x equals 2 to the negative x and g of x equals 4 to the negative x, and then how do the graphs differ? So again, we're going to use our same information. We're still going to use -2, -1, 0, 1, and 2. You'll find that it gives us just enough information to the left and the right to make the right decision. So -2, -1, 0, 1, and 2. F of x equals 2 to the negative x. So if we say 2 to the negative x, essentially this is 2 to the negative 2. A double negative is a positive, so this really makes it 2 squared, which is 4. If we follow that suit, that will give us 2, 1, 1/2, 1/2, and 1/4. Okay. Let's go ahead and do g of x while we have a chance. So g of x is 4 to the negative x. So this would be 4 to the negative 2, which by the way is just 4 squared, so that makes it 16. If we follow suit with that, again, this would be 4, 1, 1/4, and 1/16. So if we graph this information, we would have -2 and 4. So -2 and 4 is up here. Then we have -1 and 2, 0 and 1, 1.5, and then 2 and 1/4. So that graph is going to go like this. If we graph the red function, which is the g of x, I don't even actually have enough space to graph -2 and 16. It's off the chart. But I do have enough space for -1 and 4, 0 and 1, 1 and 1/4, and then 2 and 1/16. So essentially, this one would have come from way up here and stretched. Okay, so how do these graphs differ? The main thing that we would just say is that these graphs have been reflected across the y-axis. So reflected across the y-axis. All right, let's keep looking at our next one. All right, so in example 4, they're telling us already that these graphs are a transformation of 3 to the x. In other words, the functions that you see that are kind of like a lighter black, or even we may want to call that gray, they are already on the graph, and so they're asking us, how have they transformed? So in our first one, though we can't tell, it looks like the y-intercept has changed, so it looks like it's shifted up 2, but actually this has moved left 1, and we know that based off of the function. So I'm going to say left 1 unit, and again, I know that based off of the function, and this function says 3 to the x plus 1 power, so that plus 1 up there lets me know that it was moved left rather than up, okay? And this function here, however, how did it transform from 3 to the x and to -3 to the x? This one was not reflected across the y-axis, but it was reflected across the x-axis. And again, I can back that up with just common knowledge of knowing that if I have a function and it is forced to be negative, right, that makes it reflected across the x-axis. For us, in our last few problems, what makes it reflected across the y-axis is if the exponent is negative. If we try our last ones, again, we are comparing them against the 3 to the x function. And so the functions that are graphed in a bolded black line are our new functions. So we just need to find their transformation. So in this first one, I see that the function says 3 to the x minus 2. Because I see minus 2 at the end, I know that that transformation means that it was shifted down 2 units. Plus, I can see it on the graph. With the other one, it says, as compared to 3 to the x, what is the transformation when it's 3 to the negative x? We just described it on the last screen, and even in a previous example, when the power is made negative, it is reflected, I was about to say shifted, reflected in the y-axis. All right, guys, that is it for now. If you have any questions, please be sure to come see me for tutoring.